Good morning, afternoon, or evening, whatever time of day it is for you watching this. I hope you're doing well. This is going to be the first set of video notes about circuits. Today we're going to focus on circuits in series or series circuits, and the next set will be all about parallel circuits. So a series circuit is one where there's only one path for the current to flow through, only one direction it goes in, and only one path. That means if one part of the circuit fails, the circuit is considered to be open and the entire thing won't work. If this battery is dead, then the circuit won't work. If this light bulb goes out, then this one also will not be able to work. It's like if you are stringing Christmas lights and you find that one light bulb is burnt out, then the entire rest of the strand doesn't light up. That is a strand of lights that is in a series circuit. So if one part of it doesn't work, then the entire circuit is just done for. There are three main characteristics of a series circuit aligning with the three parts to Ohm's law: resistance, voltage, and current. So first, resistance. Series circuits treat resistance super easily. The total or the equivalent resistance for the entire circuit is the sum of all of the individual pieces. So here I have a series circuit where I've got three resistors, each with a resistance of 1 ohm. That means the total resistance for the entire circuit, I just add those three up, and I have a total resistance of 3 ohms. Next, there is current, the I in Ohm's law. In a series circuit, current is the same everywhere. It doesn't matter where you are in the circuit, current will be the same. And you find it by applying Ohm's law to the entire circuit. That's why you might need the total or the equivalent resistance. That is the resistance of the entire circuit. Here you could find the current of the entire circuit. And last is the voltage. Each resistor will create a voltage drop. And so if you know the current and the resistance, remember current is always the same. Resistance, you add up all of the resistors within the circuit to find the total resistance. You can use Ohm law to figure out the voltage drop across each resistor. So if I have a circuit where I've got one resistor here and I know that my current is 0.5 amperes or 0.5 amps, I know that my light bulb or my resistor has a resistance of 1 ohm. Then I can say voltage equals resistance times current. Here's my current of 0.5 amps, my resistance of 1 ohm. I have a voltage drop of 0.5 volts across this resistor. So before the light bulb, the voltage was 1. After the light bulb, it is down to 0.5. This leads us to something called Kirchhoff's loop rule, which says that the total voltage dropped in a circuit has to equal the voltage gained in the battery. Which sounds weird, but if I've got a 1.5 volt battery, that means anytime the circuit passes through this battery, that it is adding 1.5 volts. Since I am adding 1.5 here, that means across all resistors, or here across all of these light bulbs, I have to drop by that same amount of 1.5. So batteries raise voltage, resistances like light bulbs lower voltage, and the amount you add has to be the same as the amount that you drop. So if I know that this 1.5 volt battery is adding 1.5 volts, then I know that all three of these light bulbs together have to be dropping the voltage by 1.5. And I could do that if I knew the resistance and the current for each of these to find the voltage drop. We can see that also here in this idea of carrying buckets of energy. As you move up through the 3-volt battery, you're gaining energy in your little bucket. Every time you go through a light bulb, you have to give a little bit of energy to power that light bulb. You lose a little bit of that voltage. And so by the time you've gone through all of the light bulbs, all of the resistors, you have an empty bucket and need to refill at the battery. That is Kirchhoff's loop rule, and that is everything you need to know about series circuits. Up next in the next video will be parallel circuits. I hope you're doing well.